Hello and welcome back to the Robotic Enterprise Framework training. Now that we've covered the get transaction data state, it's time to dive into the process transaction and the end process states. In this video, we'll also spend some time on the set transaction status and the retry mechanisms. Let's begin. As you can expect, the process transaction state starts with a try-catch activity. Inside the try block, we invoke the process workflow file. This is where we place the activities which do the actual processing of our data. This is what happens in our process. We type the data from the transaction item into the UiDemo application and we click Accept. This workflow takes two input arguments: in transaction item, which holds the transaction data, and in config, which holds the configuration dictionary. If the workflow has been successfully executed, we set the transaction status in the same try block. Also, based on the outcome of the execution of the process workflow, we can catch a business rule exception and assign its object to the business exception variable. Note that business rule exceptions can only be thrown by a throw activity. For this type of exception, the transaction status must also be set, or a system exception and assign its object to the system exception variable. It can consist of any unhandled exceptions thrown in the process. It is, of course, necessary to set the transaction status for this type of exception as well. The robot selects the state that the process transitions to based on one of these three outcomes. A system exception will direct the process to the initialization state, while both a business rule exception and a no catch will direct it to the get transaction data state. It should be obvious by now that the set transaction status workflow is one of the key components of the reframework. We're invoking this workflow in three different places: in the first try block for setting successful status, and in the catches block for setting failed status for either business exception or system exception. This workflow is of course surrounded by a try-catch due to the robust exception handling mechanism of the reframework. But we're getting ahead of ourselves as we'll learn more about these in the following lesson. Going back to the set transaction status workflow. This workflow sets the statuses for the queue items, considering the result of the process workflow and the number of available retries. The set transaction status workflow uses quite a few arguments: the config, the system error, and the business rule exception arguments, which are used to determine the next state, as well as transaction item and transaction ID as input arguments. We can find three in-out arguments here: retry number, transaction number, and consecutive system exception. They're needed as input, but they're also altered by the set transaction status XAML file. Whether or not the robot retries a transaction, the transaction number or the retry number can change. Based on your understanding from the configuration file lesson, why do we need the consecutive system exception argument? That's right, because it keeps the count of the consecutive system exceptions. Alright, it's time to pause the video and explore on your own the process transaction state and the process workflow. Okay, ready to have a look at the set transaction status workflow? Let's do it. It's a simple flowchart which executes one of the three sequences: success, business exception, or system exception. If there is no exception, the success sequence is executed. Here, we use a set transaction status activity to change the status of the queue item to successful. When we use a different transaction item type, we need to make some changes to this workflow, as out of the box, the framework is built to work with queue items. We'll learn about this in an upcoming lesson. Yet again, we see the reframework mechanisms come into play. How is that? First, by surrounding the set transaction status activity with a try-catch activity. Secondly, with the retry scope activity that helps us to handle situations where an error occurs and the status cannot be set to successful. Remember when we've set the value for the retry number set transaction status constant in the config file to 2. Next, we add a few log fields. The most important of which being the transaction status, number and ID, and log the success message. The additional log fields are only used for this log message, hence we remove them after we log the message by using a remove log fields activity. We do this to add more information to the unique log at the end of a transaction. Okay, this covers the activities used to set the successful status. Going back, if the robot encounters a business exception while processing the transaction, it sets the status to failed, with the error type business, and the reason for which the transaction failed is set to the message of the caught business exception. The same mechanisms are applied for this status as well. The set transaction status is surrounded by a try-catch which is enclosed in a retry scope. Of course, as in the case of the successful status, we add the log fields. Log the message, then remove the log fields. Okay, we're done with the business exception status as well. It's important to note that for both the items which were successfully processed and the ones failed with a business exception, the following step is to move to the next transaction. Before we do that, we need to increment the transaction number stored in the in-out transaction number argument. Reset the retry counter stored in the in-out retry number argument to 0, and also reset the consecutive system exceptions stored in the in-out consecutive system exceptions argument to 0. Okay, it's time to see what happens when a transaction fails with a system error. This case requires that the robot takes more actions as it may need to retry the transaction. In this sequence, we first log a message with the number of consecutive system exceptions. It's important to assign the value true to the queue retry flag if in transaction item is not nothing, and the type of the transaction item is queue item. The robot uses the queue retry flag to determine whether it should execute the orchestrator retry mechanism or the one based on the config file. Equally important is that when using an orchestrator queue, if a transaction item fails due to a system exception, then the path of the screenshot is saved in the transaction item details. This way, it's easier to identify the screenshot for each transaction item. Next, we set the queue item status to failed with the error type application and the message stored in the property of the in-system-exception argument as the reason. As we've mentioned previously, the try-catch and retry scope activities help us in case an error occurs when trying to set the transaction status for this exception. Next, we add the additional log fields, count the consecutive exceptions, after which we invoke the retry current transaction workflow file. Let's see what the workflow contains. By default, the framework uses the retry mechanism in the orchestrator queue while the max retry number in the config file is 0. If the retry option is not enabled, after the first flow decision retry transaction, the no branch is executed. The next activities are a log message with the level error and an assign which increments the transaction number. This means that the robot does not retry this transaction, but instead just moves on to the next one. If in our project the transaction item is of a different type than queue item, meaning that we're not using an orchestrator queue, we can enable the retry mechanism simply by setting the max retry number in the config file to a value greater than 0. In that case, the yes branch of the retry decision is executed, and next, the robot checks if the max retry number has been reached. We don't want to retry a failed transaction forever. If the current retry number reaches the maximum value, the robot logs an error message once again, resets the retry number to 0, and increments the transaction number. But if the current transaction has been retried fewer times than the maximum retry number indicates, the robot simply logs a warning. In the case of a type of transaction item other than a queue item, the robot increments the current retry number, and that's it. It doesn't increment the transaction number value. If we do use queue items, the robot increments the transaction number. Now that we've explored the retry mechanism, let's go back to the system exception sequence. Of course, we remove the added log fields. And finally, we close all applications before executing the initialization state and starting them again. If an exception occurs while trying to close the applications, we force close the applications by invoking the kill all processes workflow in the catches block. After restarting all applications for non-queue item transactions, the same transaction is retrieved in the get transaction data state, because the transaction number has the same value if retries are still available. If a queue item variable is processed, Orchestrator deals with retries, so it increments the transaction number. And with this, we're done with the process transaction state. Let's navigate back to main. After we process all of the transactions, we get no more data, and the process goes into the end process state. Here, we can find a try-catch like the one used for system exceptions. In the try block, it will attempt to close all applications. Should an exception be thrown, the process invokes the kill all processes workflow. And finally, terminate the running workflow instance if application exceptions are encountered, and mark the job as failed or successful. So what do we want to accomplish here? Well, let's say that we need to stop the job, maybe because of too many consecutive errors. How should we mark the job as successful or as failed? So the transaction item is already marked as failed in Orchestrator, and the job will stop as configured by the developer. Does this make it a successful job or a failed job? This is controlled when using the should mark job as faulted parameter. We've set it to true in our config file, and therefore it'll mark the job as faulted. Great, this concludes this demo of the process transaction and end process states. Here are a few reflection points after this video. Do you think that you can explain the key functions of the process transaction state? What workflows are invoked in this state? What are the 3 paths the set transaction status workflow can take? How does the retry mechanism work with queue items? How does it work with a different transaction item type? What workflows are invoked in the end process state? In the next video, we'll run the process and learn more about reframework logging. Thank you for watching.